Let's take a look at some problems that generate quadratic equations. A number is 20 less than its square. Find all such numbers. So we're looking for a number. We'll let x represent our unknown. Is equals, so we'll replace is with equal sign. And then the next quantity is stated as 20 less than its square. The square of a number, which we represented as x, will be x squared, and then we want 20 less than that. This has generated a quadratic equation that, to solve, we need to put in standard form, which means we want a 0 on one side and the rest of the terms on the other. Probably the easiest would be to subtract an x from each side, and rearranging and decreasing powers of our variable, we have the following. Next, we'll factor the polynomial. This trinomial factors into the product of these two binomials, and then to solve, since we have the product of two things equals 0, one or the other or both must equal 0. Using the principle of zero products, we'll set each of those factors equal to 0, solving for the variable. Adding 5 to both sides here results in x equal 5. Subtracting 4 from either side of the equal sign results in x equal -4. So this appears to be our two solutions. Checking them by replacing the variable with the value that we found. Here we're checking 5. We see that it results in a true expression as the same when replacing x in our equation with the value of -4. So our solution to this problem would be both 5 and -4. Here's an application from geometry. It states the length of a rectangular garden is 4 meters greater than its width. The area of the garden is 96 meters square, and they're asking us to determine the length and the width. So here we have our rectangular garden. We're trying to determine the length and the width, and since they talked about the length in terms of the width, we're going to let the width be our single variable. Then, to describe the length, using the information identified in the problem, it tells us that it is 4 greater than its width. So we'll take our width and add 4 to it. Next, to generate an equation, once we have our variables established, we will use the area formula for a rectangle, which is length times width. Substituting in the length and the width that we have already set up, length will replace with w plus 4, width with w. Simplifying, we'll use distributive property. W times the first term, w times the second term results in the following. This is a quadratic equation in a single variable. To solve, we need it in standard form, so subtract a 96 from each side results in all terms on one side and 0 on the other. Next, we'll factor. Factoring results in the following two binomials multiplied together, and using the property of zero products, we'll set each of these factors, w plus 12 equal to 0 and w minus 8 equal to 0, and solve for the variable, which results in w equal -12 or w equal 8. Although both of these are solutions to this quadratic equation, we're looking for a length. So we'll reject the -12, accepting w equal 8. Replacing w with 8 will generate our length of 8 plus 4, giving us 12. So to answer this problem, the width of the garden is 8 and the length is 12 meters. Here's another application which states in a sports league of X teams in which all teams play each other twice, the total number n of games played is given by x squared minus x equal n. In a youth soccer league where a total of 240 games are played, each team playing each other twice, how many teams are there? So they're giving us the total number of games. So n can be replaced with 240. X stands for the number of teams, and that's what we're asked to solve for. What we have is a quadratic equation. To solve it, we need it in standard form, so subtracting 240 from each side results in the following equivalent expression. Next, we'll factor this trinomial. It factors into x minus 16 times the binomial x plus 15, setting each of these factors equal to 0, and solving for the variable x minus 16 equals 0 results in x equals 16, and setting x plus 15 equal to 0 results in x equal negative 15. We're looking for the number of teams. A negative number of teams doesn't make sense, though it is a solution to the equation. We're going to reject it and accept the fact that the number of teams that played and resulted in 240 games is 16. The solution to the problem.